Hello everyone, my name is Sean. I'm an application engineer here at Capture 3D. In this video, you'll learn how to automate and simplify your inspection process by using CAD and a CAD inspection plan. First thing you might be asking is, well, I already have a file that contains all my inspection points for my part. I don't want to have to recreate it, so how can the GOM software utilize it? Well, I'm going to answer that question in depth later in this video, so please watch this video through to the end. Also, if you're new to our channel, please do not hesitate to subscribe to receive the latest content and notifications from Capture 3D. Without further ado, let's get started. Okay, just some background information. First, what is CAD? CAD is a three-letter acronym that stands for Computer Aided Design, which is a perfect digital representation of your physical part. CAD holds the size, form, orientation, and location of your part's geometries. So once you start creating your geometries and your inspection points, you have started creating a CAD inspection plan. CAD inspection plan is a company-specific set of measurement criteria to achieve quality control using CAD as nominal, meaning we are going to use the perfect digital representation to compare your scan data to. So when taking advantage of this inspection plan, we can see some benefits. Generally, using a CAD inspection plan can streamline your inspection process by creating a robust process that can be repeatable. We can utilize CAD inspection plan during multiple stages of a manufacturing process and at different milestones, like a PPAP, first article, and process capability studies. With that background information, we can take your company's inspection plan and directly create it within the GOM software. So in the GOM software, we can use CAD to offline build inspection methods on the parts. These parts are usually part multiples of the same part that are being measured and inspected. How do we do that? Is by following three simple steps. First, we construct the nominal geometries using the CAD model. Next, we apply what we call a measuring principle. A measuring principle is a method that the software will create the actual geometries using the nominal geometries from the CAD. Lastly, we apply a check. We check those actual values to the nominal values that we get from the CAD. So what are some of the benefits specifically using CAD in the GOM software? In the GOM software, we can create project templates containing the CAD, all the nominal geometries, and measuring principles applied to your part. That means we will save you time because you will not have to keep recreating those geometries for similar parts. Also, take a step further. With GOM's VMR module, we can create an automation path that efficiently focuses on your inspection plan and criteria in the realm of automation. In turn, it reduces unnecessary time and movements of your robot. There are some major benefits of using CAD and a CAD inspection plan in GOM software. But say you already have a file that holds all this inspection information. File like a CSV or an ASCII. We can import those files into the GOM software, and we can also import a CAD that has the inspection plan embedded into the CAD file itself. Depending on the software you use, that plan could be called an FTA, PMR, or MBD. So I want to demonstrate how to create a simple CAD inspection plan using the GOM software. So what we're going to do is start a new project. Okay, this is the workspace we'll be doing all of our inspection in this video. So the first thing that we're going to do is bring in our CAD body. Again, we're going to be working with a sample part that GOM has provided. It's called the GOM block. I'm going to use the import method of the drag and drop method. So first thing I'm going to do is open up my file explorer. So I'm going to bring up my file explorer. I'm going to go to the location my CAD is at. For me, I have it in my tutorials videos. So I'm going to click my CAD body, the step file up top, and just drag it into my project itself. Next, it'll bring up this import dialog, give you multiple different options. For now, I'm going to do a new part. bring up this parameters dialog. For now, we're going to leave it at a medium mesh resolution, and we're going to keep the transformation into the global coordinate system. So I'm going to hit OK. So one thing is, when we brought this CAD body in, it brought in this coordinate system. I want to hide that coordinate system, so I'm going to have it selected and hit I for invisible. I'm not deleting it, I'm just hiding it from my 3D view. I'm going to hit I to hide it. So one cool feature in the GOM software is that we can simulate a mesh. So what we're going to do is create a copy of this CAD and simulate it as a mesh. So first things first, I'm going to just left click my CAD. I'm going to go up to operations, go down to CAD, and go to CAD to actual mesh. So you'll get this dialog name. I'm going to just leave it automatically generates a name. But what I'm going to use it for is actual data simulation. So the reason why I do this is so that, because one, I don't actually have mesh actual scan data that I have. So what I'm going to use this for is a good check to make sure that what I am creating works well. So now I have an actual mesh in my project and a CAD in my project. So now the next step I need to do is to create an alignment. So I need to make sure that the software knows that my mesh is aligned with my CAD body itself. So it's going to move the mesh to my CAD. So what I'm going to do is go up to the top right for this create alignment tool. I'll create initial alignment. The initial alignment that I'm going to use is a pre-alignment, which is just a global best fit. If you want more in depth about alignments, we do have another video on our channel for alignments. But for now, again, I'm going to just use this pre-alignment. So we're going to get the name. We can change it a name if we want to. The next part is the part. So what part we're using. If we're going to align it to a different CAD body, we can. We just use this target element. The next parameter is this search time. The search time is just how long is the software going to take to find that best fit, this global best fit. So if you do a drop down, you got short, normal, and long. Usually when we use short, it's usually the part has enough complex geometries that it will take a little bit less time for it to find that global best fit. And long is when we don't have as many complex geometries to find that best fit. Those are just a rule of thumb about which one to use. So for now, this one has enough complex geometries to fit to align to, so I'm just use short. Again, this global deviation will get down to as close to 0 as possible, but usually it's not going to be exactly 0. So we'll hit click OK. So now our CAD and our mesh is aligned in the software. So now I can start creating my inspection plan. So what we're going to do is go up to the top left, go to the surface comparison drop down. I'm going to do a surface comparison on CAD. So what it's going to do is start at the CAD and go up or down and find the actual mesh to find that deviation. So you'll see the name again, which actual element you're using. It's going to default to the automatic. This max distance, how far away from the CAD is it going to search for the mesh? If you have a less rigid part, a flimsier part, you probably want to bump this up a little bit. For now, I'm going to leave it at 10 millimeters, and then you can add your tolerances down here. You can have no tolerances from CAD. If you have patches on your CAD that has different tolerances than other patches, you can use from CAD, or you can enter them manually. So for now, I'm just entering global tolerances of 0.3 millimeters, and then I'm gonna hit OK. So everything is green for now because again, we are using a copy of the CAD as our mesh. So from here, colors are great, but we still need some deviation labels, something that will denote actual numbers. So we're going to go up to the top ribbon up here. We're going to move 2 over to this pointwise inspection drop down. I'm going to click it, go down to deviation labels, and it'll start this operation. So with a lot of these features, it'll bring up this kind of instruction dialog at the bottom. So if you forget what you're doing or what you need to be doing, just follow the steps down here. So I'm gonna hold Control to do preview. And now I'm just going to left click around and just start adding reference or deviation labels. Again, you'll see 0 because we are using the copy of the CAD. We'll right click to get out of that operation. One thing that we can do, say we just want to see, we will also want to see the maximum deviation in this, for this heat map, this color map here. So what I'm going to do is go up to inspection, go down to max slash or min slash max deviation labels and click it. You'll get this dialog. So now it'll tell you what the deviation name or the name for this deviation label and this deviation type. If you drop it down, you can look at maximum deviation labels, minimum deviation labels, and all this other options down here. But for now, we're going to just do a minimum deviation labels, and we'll see what this area is I have. I just need to select the area of interest. So what I'm going to do is go down to my 3D selection tool and select all. Click OK, and you'll notice that it selects it down here. Next, I want to do my maximum deviation labels. If you just click the OK right here, it will just keep you within the dialog box that you already have. So I'm going to do it again, do maximum deviation labels. I'll have to again select the area of interest. So I'm going to just select all because I want to know of the whole thing, where is my maximum deviation label. For now, I'm going to click this door close for create and close. And they'll be in the same spot with 0 deviation. Cool, now we created a surface comparison, so I'm going to kind of line it up, make it look nice. I'm gonna create a quick little report page. So I'm gonna go up to this top right to this create report page button, click it. It'll give me a preview of what I have. I can select my styles down here, but for now I'm just going to select, I'm going to rename it to surface comparison. I'm going to click OK. Now I have my report pages starting to populate down here as well. From here, the next thing I want to do is I want to look at a specific section cut. I'm going to look at a color map at a specific section cut and add some equidistant deviation labels on that section cut. This section cut with this color map is called inspection section. So first thing I want to do is bring out my CAD exclusively. So I'm actually going to select my CAD and drag it out and show exclusively. So now I have it exclusively shown. So first thing I'm going to do is go up to my toolbar, go to inspection section right beside the surface comparison drop down, go to the inspection section. For now, I'm going to do inspection section on CAD. So now I can select my reference plane. So what plane am I referencing off? So I'm actually just going to do X, and then what position, so how far away from that reference plane I'm going to go. I'm going to just leave it at 0, 0. Again, it's going to, after that, it's very similar parameters as the surface comparison. I'm going to keep my max distance at 10 millimeters. And here I can add my tolerances again. So I'm going to put 0.3 and hit create and close. So now I have my inspection section. So to get my inspection section viewed with my CAD, what I'm going to do is actually go to my picture-in-picture, my PIP. I'm going to go, it'll bring you up this little view. So next I'm going to go to the right side of it, do this drop down. I'm going to do clipping at element plane and select my inspection section so that now I clipped my CAD body at the inspection section plane. So now I'm going to take a look at it. I'm going to look down the x-axis to look down. I'm going to hide my picture-in-picture for now, and now I can see my inspection section. Okay, so from here I want to create equidistant deviation labels. So I'm going to go up to the top. Instead of doing deviation labels, I'm going to do equidistant deviation labels. Okay, from here I want to again follow the directions at the bottom. I'm gonna select my start point. I want my start point at this corner over here. And I need to select my points in 3D view. So I'm going to have my inspection section selected. I'm gonna right click it, go down to select points of all element, and then it starts showing equidistant deviation labels. If you want them closer together, you can click the down arrow, or you can just drag your mouse wheel. If you want to do bigger increments, you can actually hit shift and it'll do bigger increments, or if you want smaller increments, you hit control and you can move it in smaller increments. So for there, I'm going to go ahead and like the way I see it, so I'm going to hit create and close. I'm going to drag off all these deviation labels a little bit off my part so it's not doesn't look so messy. Okay, so from here I'm going to create another report page. So I'm going to go back up to this create report page button, click it, and again it gives me this nice view. Now I'm going to call this inspection section. Okay, for here I'm just going to click OK, and I created another report page. So the next thing I want to do is create these color maps and everything is great, but I want to start doing specific distances and look at some of our geometries. So first thing I want to see is what the difference is between the width of our GOM block. So one thing I want to do again is I want to make sure my CAD is exclusive. So I'm going to click my CAD and just drag it out. Okay, so I want to do a basic distance check between the width of our GOM block. So how I'm going to do that is I'm going to go up to the top toolbar, go to construct, and I'm going to go to distances. And there'll be a lot of different distances that you can look at. One thing GOM has tried to do very well is mimic CMM distances and physical distances that checks that we do. So what I'm going to do is actually I'm going to pick this outer disc caliper check, and it'll bring up this dialog. Before I start creating anything, I just want to go through some of these parameters. Clearance is how far away from the part it's going to start these calipers and move in. The radius is you'll see in a second, is how big of a disc that it creates and how much data it's going to basically take into factor when moving from the start point into the part. And then you just have to select these points that you want to select on the CAD body itself, and then you got this compute direction automatically, and it'll make more sense once I start creating this. So first thing is I'm going to hold control, select my first point, and then I'm going to go to the other side and hold control and select my second point. So now I have 2 points. I can sit here and select the compute direction automatically, and I'll select my direction. But for now, I want to force it into the X direction. Just be aware which direction you are actually going to inspect your parts in, is how far away it's going to start these calipers to move in on your part. So for now, I'm going to leave it, we'll do 5%. And then the radius, I'll zoom in real quick for you. This radius again is how big your disc is going to be. So for now, I'm just going to leave it at 30 millimeters. Next thing, I have to make sure, select the points I want in 3D view. So for now, I'm just going to hit select all and hit create and close. So now we created that distance. You'll see this error. So now we can actually see what that error is by hitting tab to bring up our properties window, or double click it. So I'm going to double click it, and it'll say the measuring principle was missing. So just a basic of what a measuring principle is, it's how the software is going to create this exact distance on the mesh itself. So if you want more information and a deeper dive into measuring principles, we also have another video on measuring principles. So I'm going to bring up my eye inspect wheel. It's right beside the point-wise inspection. It's this button right here. Or the hotkey is Control right click. So from here, I'm gonna click this. I'm gonna start at about 1, 2 o'clock position, and for this measuring principles. And based on how I constructed it, it's gonna be a reference construction. Okay, so now you see that error went away in this label up here. So now I gotta check it. So I'm gonna go to check, and you'll get these different options. So this distance, this top distance is just the shortest distance between those 2 points. And then you can restrict it in which axis direction you want to look at. For now, I'm just going to do the shortest distance. And here I'm going to enter in my tolerances here. In this parameter up here, you can do a drop down if your CAD doesn't match your print and you are looking at a different nominal value. You can go against fixed value, but for now I'm going to pull it from the CAD, so I'm going to do against nominal, and then enter my tolerance manually. So for this one, I'm going to put 0.5 millimeter tolerance and click OK. So now I have my first distance check. So you'll see in this label up here, you'll see the element type. It's a length check. And then you'll see the nominal value, the actual value, and then the deviation. And then this cat and whisker plot check visualization of where it will be in the tolerance band. So now if I click off of it, that distance check is hidden. So one thing I want to do is kind of mimic the drawing itself. So what I'm going to do is actually line up my 3D view. We'll select this L in my label, and you'll get this blue box. I'll drag it out to make it look all nice. I'm going to hide this distance 1, this element distance 1. I'm going to hit I for invisible. And now I have this distance 1, the length check shown, visible in my 3D view with my CAD. So now again, I'm going to create a report page for it. And we'll just name it width check. I'm gonna click OK. Okay, so we did a distance check on this thing. So now we'll go a little more complex. I'm gonna do a diameter check of one of these cylinders. So again, I want my CAD exclusive, and I'm gonna actually show you a different way how to make your CAD exclusive. I'm gonna select my CAD and hit E for exclusive. So now all it will show is my CAD in my 3D view. So next I want to construct a cylinder, this top cylinder, and then apply that a measuring principle and then check it for its diameter. So now what I'm going to do is go up to construct, go down to cylinder. First one I want to use is this auto cylinder nominal. Usually use this again when you're doing inspection planning or inspections on the CAD itself. So next I'm going to select the cylinder that I want to use. Again, if you forget what you're doing, just follow this dialog at the bottom. I'm going to control select my CAD and it'll bring up the cylinder 1. All these elements, if this is grayed out, will automatically pull it from the CAD body itself. So for now I'm going to leave it as default. I'm going to hit create and close, and it created it on the CAD body. Next I have to create or apply a measuring principle. So I'm going to hit control right click, go to my measuring principles, and here we're going to do a fitting element. Again, for now I'm going to leave these as default. Again, if you want to dive deeper into what these parameters are and what measuring principles are, please check out our other video that is specifically on measuring principles. For now I'm going to leave it at a Gaussian best fit and use points as 3 sigma and click OK. So now you'll see that error change, and you see it change from this a red color to a blue color, meaning we've applied a measuring principle. And there's no errors for this part itself. Next, the last step is to check it. So again, we'll go to this check slice on my inspection or my eye inspect wheel. I'm gonna go down to diameter, and you get the same similar dialog box. I'm gonna enter in my tolerance manually. I'm gonna just put 0.1 as my tolerance and click OK. Cool little thing that we can do is, say I accidentally put in the wrong tolerances for this, I can actually hit tab and go to my properties window and then go down to my tolerances and add tolerances here. Say I didn't want it's a asymmetric tolerance, so what I want to do is click this unlink button and move my tolerance, my lower tolerance. So I want to do a negative 0.05 tolerance on the low end and click OK. And now I've changed my tolerance band for this specific check. So again, I'm going to just make it all nice and neat. We'll just create a report page and just click OK. And that's how you do a diameter check. So the next thing I want to show you is some GD&T. So what we can do in the software, we can do GD&T. If you want to look at some GD&T some GD&T checks that we can do, just go up to the top up here, right beside the eye inspect wheel button, right here. And these are all the GD&T callouts we can do in the software. So just to do a quick GD&T check, there are quick creations. I'm going to actually do just a flatness check. But first I'm going to actually make my CAD exclusive. So I'm going to select my CAD, have it exclusively shown. And now I'm going to go to my quick creations again, do a flatness check. I'm going to do a flatness check on this top plane right here. So again, this quick creations is going to create a plane, apply a measuring principle, and then do the check that we want to, kind of an all-in-one step. So what I'm going to do is have it selected, select the plane I want. So you see it creates that plane, applies that measuring principle real quick, and now brings up this dialog. So now we want to add a tolerance. So I'm going to do 0.1, and we'll click OK. And I'm going to just right click out of it to just get my check by itself with the CAD. And again, I'm going to create a report page. Click OK. And there we go. We did a quick GD&T check really quickly. We've created, through the software, we've created basically what we call a project template. So from there, we can go into a lot more inspection. If we want, we can keep adding stuff if we want to, but for now, I think that's good. So what we're going to do is create a project template. So that's what we've been building this whole time. So what a project template, again, as a review, is everything in our software except the mesh. It's going to save everything except the actual mesh. It's going to save the CAD, the nominal geometries, and those measuring principles, and even the report pages. So again, it'll save you time later on, so you don't have to actually recreate those inspection points again. So it will save you time in the long run. So what we're going to do is go up to File, Create Template from Project. Okay, so I have a lot of these, so I'm going to just click this training, click OK, overwrite one. All right, so we've just created our inspection plan. This whole time we've been inspection plan before we even started scanning a part. So now we've created a project template. Again, this project template is going to contain just the CAD, the nominal elements, and the measuring principles. So whenever we drag and drop meshes in, it will be able to create those geometries on the actual mesh itself. And it'll also save the report pages so you don't have to recreate those every time. It is a lot of front-loaded stuff work, but it will save you time in the long run. So how to create a project template from this point, we'll go up to File, Create Template from Project. It'll bring you up this dialog. So if I want to, I can mess with the preview image up here. We're just gonna have to name it. For now, I'm going to call it my CAD inspection plan. Go block. Okay, from there, I can add a template description. So just go and block inspection plan, and then now I'll just hit OK. If you want to change the 3D view, you can to what it sees in 3D view. And we'll just click OK, and there you go. I created a CAD inspection plan or project template within the GOM software. So from there, if I want to bring it back open, I can go back to the Start workspace, go to Set a new project. I'm gonna go down to my project templates. I see that my CAD inspection plan, so I'm gonna click it. I'm just gonna delete project. If you want to save it, you can. I'll just click delete project for my sake for now. Okay, so this is my project template. Again, if I look at my Explorer, it'll say it has a mesh in it, but if you actually show it exclusively, there's nothing there. So now some time has passed. I've started scanning this GOM block. I have my mesh. So what I want to do now is actually open my file explorer, go to where I have this all selected, my tutorial videos folder, wherever my meshes are located. And now I'm going to select my meshes. So I'm going to just drag. For me, again, I'm going to use the drag and drop method. I'm going to just drag it in. For this one, looks a little different than we saw before. Instead of new part, we're going to do replace in part because we're going to place that mesh file. So we'll do replace in part. Okay. Now you see this is why we've created that alignment, because when we actually bring in mesh itself, it's going to have it's going to be in a different coordinate space than the CAD body itself. So from here, we want to recalculate everything. So I'm gonna go up to this top, recalculate project. It defaults to without report pages, but I do have report pages in there. So I'm gonna recalculate projects with report pages. Now if we move into our report workspace, now we see that we have a inspected part. So quickly, I'll show you. This doesn't look all great, so I can still kind of come back and edit my report pages. But now you have a inspected part. Again, you can basically do this with all the other inspections that you have or all your other meshes. You can just drag and drop into this project template. Well, I hope that helped you out a lot. But that's the end of this little short demonstration. To summarize, a CAD is a perfect digital representation of your physical part. When you create your company's inspection criteria on the CAD, you have a CAD inspection plan. CAD inspection plans are then used throughout the manufacturing of the part to streamline the process and to verify that your physical part is within spec. We use CAD inspection plans in the GOM software by creating project templates, so you don't have to recreate the inspection plan every single time. Lastly, we went through a short demonstration on creating a simple CAD inspection plan within the software. So, if you want more information on the GOM software, ATOS, or Capture 3D, please visit our website at capture3d.com. Also, don't forget to subscribe to receive the latest content and tutorials from our channel. Again, my name is Sean. Thank you for watching.